Okay, so this is the Unit 1 Linear Systems review questions for the exam. I'm going to show you the solutions to these while I talk you through them. So what we're doing first is the non-calculator portion, and so obviously you're allowed the 4-function calculator but not the TI Nspire. So what we're doing is we're solving systems of equations by elimination, and so remember our end result should be two answers, an x value and a y value. For the process of elimination, what we're going to try and do is add or subtract the equations so that one of the variables are eliminated. In this case, if I go ahead and add those two equations, they're already in line. I get 4x minus 4x cancels out, minus 5y plus y is going to leave me with minus 4y. 14 minus 6 is going to leave me with 8, and I've already got y by itself. I'll divide both sides by minus 4, and that will yield the y value in this case of minus 2. The next thing I need is to substitute that back in to either equation in order to find the corresponding x value. So I'm going to pick the first equation, 4x minus 5, sub in the value of minus 2 in the place of y, and I've now left with a linear equation which I need to solve. And so minus 5 by minus 2 leaves me with plus 10. Move the 10 to the right hand side, so it becomes subtract 14 minus the 10 leaves me with 4, divide through by 4, and I have my x value of 1, y value of minus 2, x value of 1, and that's the first question. Okay, second question is slightly different. You can see the way it's been arranged. They still line up nicely. Y's line up, then the equals, then the x's, then the numbers. And so we could rearrange this, but it could also be done as is. And so the y's are already the same as each other, but this time what I'm going to do is subtract. So I have y minus y is 0. 3x minus 2x becomes plus 2x. So I'm left with 5x. 4 minus 1 likewise becomes 4 plus 1, which gives me 5. And now I need to solve this equation over here. So I'm going to move the 5 to the left-hand side. So I can do that by subtracting 5 from both sides of the equation. And I'm left with minus 5 is equal to 5x. And therefore x is equal to minus 1 if I divide both sides by 5. I need to substitute that back in. Once again, I can substitute into either of the equations. So this time I'll pick the second equation, y is equal to minus 2 multiplied by x minus 1. In this case, we sub in our x value of minus 1, and we have therefore y is equal to minus 1 multiplied by minus 2 is positive 2, minus 1 leaves us with 1, and we have our x value of minus 1, our y value of 1. Okay, process for question C is the same, except what you can see here is that the equations are not aligned. So the y's align with the x's, the equals are not aligned, and so what I need to do in this equation is begin by moving the negative 3x term to the left-hand side, and I can do that by adding 3x to both sides. And so if I do that, I'm going to get 3x plus 4y is equal to 11, and essentially all I did was move that minus 3x to the left. It became plus 3x, and then plus 4y equals 11 is the same. Now I'm going to focus on these two equations here, and you can see the x's already align. They have the same coefficient, and so I'm going to subtract the two equations. 3x minus 3x will cancel. 2y minus positive 4y, so that becomes 2y minus 4y leaves me with minus 2y. Minus 5 minus 11 is going to leave me with minus 16. divide both sides by -2, and I have my y value, which is 8. I now need to substitute back in order to find the corresponding x value. Once again, I can pick any equation, and so I'm going to work with the second equation. 3x plus 2 multiplied by y is equal to -5. Y value that we worked out was 8, so I have 3x plus 16 equals -5. The 16 moves to the right hand side and becomes -16, so -5 minus 16 minus 21. Divide both sides by 3, and we have our x value of -7. Okay, and now things get slightly more complicated. We cannot go directly to the adding and subtracting. As you can see, the x coefficients are 1 and 3, the y coefficients -2 rather, and -1. And so none of those have the same coefficients, and so what we're going to have to do in this case is multiply first. Several different choices. What I'm going to do is multiply the second equation by 2, and that is going to result in an equation of 6x minus 2y is equal to 8. And now you can see, if we focus on the first equation and the newly modified equation, we have got the y is the same. In other words, the coefficients are the same, and so in this case I will subtract in order to eliminate. So I have 1x minus 6x, which will leave me with minus 5x, minus 2y, minus, and a minus becomes plus 2y, so those are going to cancel out, and then I have minus 7 minus 8, which is going to give me minus 15, and now the y's are eliminated, and I can divide through by the coefficient of the x and find the x value of 3. I'll now substitute that back in, and this time I'll use the first equation. 1x, which is just going to be 3 minus 2y, is equal to minus 7. Do some quick rearranging. The 3 moves to the right hand side, becomes minus 3, so minus 3 minus 7, minus 10. Divide both sides by minus 2, and I have y equal to 5, x equal to 3. All right. And lastly, in the elimination, the most complicated version. And in this most complicated version, we are going to have to do 2 multiplications in order to get the coefficients to line up. And so in this case, what I'll do is I'll multiply the first equation by 5, the second equation by 7, in order to get the y's to line up. The alternative, of course, is using 6 and 8 for the x's, but in this case I'll just use the y's. So we have 5 multiplied by each of these terms, so we must distribute, and that's going to give me 40x minus 35y is equal to minus 15. Do not forget to multiply the 5 by the minus 3. In the second equation, I'm going to have 7 sixes, 42x minus 35y is equal to minus 7. And in this case, I will subtract once again. 40x minus 42x will leave me with minus 2x. Minus 35y plus 35y will cancel. Minus 15 plus 8 leaves me with minus 8. And once again, divide through by the coefficient of the x, and I have the x value of 4. I now substitute that back in to one of the equations, so I'll use the first one this time, 8x, so it's 8 times 4 minus 7y equals minus 3, so that's 32 minus 7y equals minus 3. The 32 moves to the right hand side and becomes minus 32 minus 3 is going to give me minus 35. Divide both sides by the coefficient of the y, and I have a y value of 5. Okay, so save those, and then we'll move on to the second page. And again, we are focusing at this point on the non-calculator systems. So in this case, what we're doing is we're solving this system by hand, and we're solving graphically. And so what you need to be able to do in this case is identify, first of all, the b value, which of course is the y-intercept. And so I'm going to mark that excuse me, on the graph at 1, and then minus 3 is of course the slope. And if the slope is minus 3, that in fact is minus 3 over 1, which means 1 to the right and 3 units down, and that's because of the negative. And so from this point I'm going to go 1 to the right, 1, 2, 3 down, and that'll be the second point on my line. And what I'll do is draw a line through there, and so passing through both of those points, we'll just extend the other side. Okay, and now we need to graph the second line. Same approach. In this case we have minus 7 as the y-intercept, and so it's going to cut the y-axis at minus 7. The slope is 1 over 1, which means we have a rise over run, 1 up, 1 to the right. To get my second point, once again I will use the line drawing function, and we'll just modify that. Okay, and then the final piece is to read off the coordinates of the point of intersection, and so we are allowed a margin of error here because we're graphing this by hand. You can see here we're at approximately 1.5 on the x and approximately minus 3.5 for the y, and that would be the solution: x value of 1.5, y value of minus 3.5. And the last thing that remains is just to provide a couple of labels. This of course is the point 0, 1, and this of course is the point 0, minus. Oh, and I've just spotted my error. That should in fact be minus 7. So let me just go, my apologies, and make a quick correction. And so we need to just redo those points. So mark that one incorrectly, so that should be minus 7, 1 up and 1 across. And now we're going to draw our line. Okay. And I'm just going to artificially extend that. I should have made that a little bit longer, but now we can read off our intersection point. This time is going to be at 2 and minus 5, and this gives us our solution, and I'll label this one correctly this time, 0, minus 7. Okay, so I'm going to stop the video here at this point before I run out of time, and I'll continue with question 2b on the next installment of the video.